Hey guys, welcome to the Tech Career Booster channel. My name is Josh Ballardine, and in today's video, I'm going to be talking about jargons in the IT area. So if you don't speak dev's language, stay with me and learn how to talk like a developer. Um, Today, we are going to be touching some of most common acronyms and jargons devs usually speak, or people usually speak when they are talking about software development. It's good to be familiar with that because you're not going to look dumb, or you're not going to look too beginner when you are in a conversation or when you are in a job interview. So my goal today is not to go too deep on these concepts and these things. Some of them, they are very complex and they can become a whole class or a whole course just for that concept. And definitely that's not my goal, to be explaining deep all of them. I want to just give you a brief idea on what it is. And then with that, you're going to be able to navigate through that and actually research a bit more if you are interested in. So if you want to speak dev language, stay with me and let's learn it. Let's go for the first one. First one you probably heard about is algorithm. What an algorithm is? Algorithm is basically a sequence of steps to solve a problem. That's the way we tell the computer what it has to do. So every time you hit a button or you fill a field or whatever you do, there is an algorithm behind that which is going to run and execute some action. Basically, if we go back to basics of the computer, what we are doing when we are using a computer or even a mobile these days, uh, we are basically inputting some data, processing that, storing that, or reading that, processing that, and delivering to the user. Basically, that's the steps we do every time we interact with a mobile or with a computer or something. And an algorithm is what tells the computer how that processing should run. So what's processing means? That's what the algorithm is going to do. It's basically step by step. It's like a recipe. If you think like an algorithm, like a food recipe, it's something you're going to do this step, and then this step, and then this step, and then that's going to solve a problem. That is what an algorithm is. Simple, isn't it? It's easy to say, it's hard to do. You're going to find like some of the algorithms, they are very complex for doing some very specific tasks. But yeah, it's beautiful thing when you actually learn that and understand how to use it to do your software and their things. Basically, that's the base of your software. Whatever you're going to do, you're going to have an algorithm behind that. Let's go to the second word, which is API. That's an acronym for Application Programming Interface. And what does that mean if you've never seen that? You probably heard about APIs and in the context of connecting things. So that API is basically an interface for a computer to talk to another computer, or for a system to talk to another system. Don't confuse that with networks. That's how computers talk to each other. It's not like a network, but it's the way one system sends information or read information from another system. So the API is that interface. It's like a combination. It's like a protocol. You combine, you agree how you're going to talk. For example, in our world, we agree which language you're going to use to talk. At this time, I'm using English, which is even not my mother language. My mother language is Portuguese, but I'm speaking in English. And you guys who understand English, you're going to understand me. So that's our interface of communication. And an API, basically, it is the interface. What's the language two systems are going to talk to understand each other? So that's the definition of that interface, the rules of that interface. That's what's called API. And that's going to lead us to another term you're probably going to read very close to the APIs, which is REST. And don't confuse that with resting when you are tired. It's not like that. It states for representational state transfer. Again, something if you never heard about, it's going to be what that means. That's a set of rules which guides the APIs. So REST is basically one of the architectures we can use to build APIs on top of REST architecture, which is going to be the representation of the data, basically, and that's going to be based on HTTP methods. We're going to be talking later about what HTTP is, but HTTP has some methods, and REST is based on those methods. That's one architecture for using APIs. Another term we have is actually IDE. That's very common. Probably even if you are a beginner, you probably have downloaded an IDE, which is an integrated development environment. That's basically the tool you're going to be using to write your code. So an IDE is an environment which integrates a text editor to type your code, and probably a few other tools to actually help you to run and debug your code. And again, you just listen for the next one, which is debugging. But an IDE is basically the tool you're going to be using. So it can be like Visual Studio, PHP Storm, many IDE tools we have for different languages and different purpose, but it is the software. IDE is the software you will be using to write your code and create your systems and your code. And I just talked about the other one you're going to be using inside of an IDE, which is debugging. What debugging means? Debugging means you're going to be running your code step by step in order to find bugs, in order to find mistakes you've made or someone else made and fix them. So debugging is basically understanding each line of the source code, understand what it's doing, and see the results. After each line running, you're going to see what's the result after doing this, what's the result after doing that, what's the result after doing the next one. And the reason for doing that is actually trying to find what the mistake is. Probably you're going to be debugging stuff when there is an error, when there is a problem. So if you find a problem or something wrong in the software, which we call bug, so you're going to be debugging or trying to get rid of the bug. Another common thing you probably heard about already, if you are researching or if you are keen to actually get into the area, you probably heard about front-end, back-end, and full stack. Basically, that's the three major types of devs, or three major things we do as a software developer. Three types of software we can tell. And what front-end means, not just type of software, but also this term, it confuses itself with what the dev is or what his preference, and also what he's working on. Sometimes you are full stack, but you are working on front end. Or sometimes you are full stack, but you are working the back end. So what front end and back end means? Front end basically means whatever is running in the client side. So when we talk about client side, in the web, it is the browser. So whatever is running inside of the browser, the interface you can see, that's front end. Whatever you interact with is front end. If you were talking about mobile, a phone or a device, the front end is the app itself you are interacting with. So that's what the front end is. And then we call the front end dev, the devs who are focused on creating those interfaces. So the ones who are focused on creating those fancy and nice interface, either in a mobile or in a web, inside of the browser, they are called front-end devs. On the other hand, backend is what happened behind the scenes, usually in a server. So when we call backend, we are talking about heavy processing. We are talking about hard lifting work, and usually that's where everything happens. When we store data or when we process a lot of a huge amount of data that's happening in the backend. So for software to exist, for software to work properly, 99% of the time we have to have front end and back end. They work together. So the front end is the interface, is what the user is seeing. The back end is what you can't see, but it's where the magic is happening. It is where we store data. It is where you retrieve data from. It is where you do all the combinations and all sorts of things to actually make whatever your software have to do, any processing and anything. And then we have the full stack, which is basically the combination of both. Full stack is sort of a role for dev. So when we say a dev is full stack, it means it can code for front end and for back end. Some devs, they have their preference. They can only code for one side and they don't like the other one. That's the most common thing. Usually back end guys, they don't like front end. Front end guys, they don't like back end. And full stack doesn't mean they like both, but it means they actually can do both. So if you are thinking of become a dev, that's a good thing to actually think about. You're going to have to be understanding what's your preference. You have to have self-knowledge to see what you want to do, basically. If you find yourself more interested in actually doing nice interface and visual things, more close to the graphic designers, you're probably going to go to front end. If you really don't like to spend time moving things around or changing colors or doing like small things or even creating some fancy interface, when you change one thing, another thing is going to happen, creating step processes in the front, in the interface. If you really don't like that, so backend is your world. You're probably going to be happier in the backend just coding heavy stuff, which most people can't see, but they love the results. Next term, what else we have here? We have OOP. What OOP means? It's object-oriented programming. It's basically a way to create your software. It is, when we talk about languages, there are many approaches you can use to write your code. And object-oriented is one of the approaches you use where you organize your thoughts, you organize your mind as you are coding objects. You have objects and then you code the things around those objects. So it's basically a code. I would not say an architecture. It's not a code architecture. It's a code style. It's a way of coding. And then we have languages, some programming languages. They are object-oriented. Some programming languages, they are not. And some of them, you can do both. So depending on the language you are using, probably you're going to have that concept built in the language, which you can actually use that. For example, you can create classes and methods, which is related to the object-oriented programming style, or some languages, they don't allow you to do that. If you're not allowed to do it, if you don't have the proper commands in the language, you can't use object-oriented programming. So it's basically a style of programming usually built in the language. And what a framework is, you probably have heard a lot of things about frameworks. Even they are confused with some languages. Sometimes people think the framework is the language is the framework. And the framework is basically a set of code already done for you. So someone already coded a lot of common things and they organized things in folders and stuff. And that's what's called a framework. So they create a lot of heavy work you're going to do later. It is already built in the framework. So it's basically if you can get something half done for you, not half done, but you can get a lot of components from a framework, for example, and you put those components together, and then you're going to create your software way easier. The main goal of the frameworks is actually to speed up your developing. So using a framework is usually a way faster than building up things from scratch. If you have just the raw language, the raw programming language, and try to build something from scratch, you're probably going to be worrying about a lot of things which the framework is already worried for you. For example, some of the backend frameworks, they are worried about security. They're building the security for you. They can actually filter the data you were reading. They can organize the stuff. So the framework is basically something to actually speed up your coding. It is a set of, I would say, not a set of objects, but a set of pieces of code already built for you to do specific things. Obviously, usually common things, not very specific, but usually things we have to do for all the systems. When we talk about security, when we talk about user authentication, when we talk about data storage and retrieving, all those sorts of things, usually the frameworks have built in already. Or when we are talking about a front-end framework, usually have like components for the front end. It have drop downs, it has like drag and drop stuff. So that's all built in the framework, ready for you to use. While if you are not using a framework, you're going to have to build that for yourself. Like you're going to have to build the drag and drop stuff. You have to program how you're going to drag from here and like drop in there. So frameworks are our friends and they can help us. Another word you're going to be hearing is refactoring. And what a refactoring is, refactoring basically is enhancing your code without changing the output. So if you want to enhance your code, or if you want to split that in different files, or if you want to just make that more readable for other devs, that's what refactoring is. So usually when we have sort of mess in the code, we start small, we start experimenting things, and that works, that thing is going to work, and then it starts to become bigger and bigger and bigger, and then you end up with a whole mess of things in one file. Then you want to say, okay, in order to grow that and put that in production, I'm going to have to split that in different files. I'm going to have to split that in different functions, in different methods, or create a new class or things like that. That's what refactoring is. Refactoring is changing and enhancing your code just for sake of enhance itself, not for improving the user experience. Sometimes refactoring can improve user experience, especially speed, but most of the time, the user is not going to perceive any difference. The user is not going to see if you change something, unless you introduce a bug. But if you just refactor the code without introducing any bug, the user is not going to see much difference, but the difference is going to be for the dev team. Usually we are working in teams, and then those teams, they need to understand the code better in order to do the job. So refactoring is basically helping the team to understand the code better later on. And another term we have here is SQL, or SQL, as some people say, and that stands for Structured Query Language. That's related to database. That's a language to actually retrieve and save data to a database, especially relational database we're talking here. So that's a special language. Usually they're used for database admins and software developers when they have to store data and retrieve data, especially to retrieve data because we can have very complex and long queries to actually retrieve the data in the way we want, in the proper way. Next term, you probably will be hearing about MVC, or Model View Controller. That's a way to organize your code when you are creating a system. And we talked before about front-end and back-end devs. In this Model View Controller, usually there is a way to split that in more than one dev. For example, some devs, they're only going to work in the views, which is the front end, which is the first part where the user going to see stuff. And then the model is another layer. So we call those layers. One layer is view, is like the front end. Another layer is the model, which is the database. It's data where you store and retrieve data from. So that's your model. We call data model. And then we have a controller in between. Controller is the middle layer, which is going to make those two communicate with. So the controller is the one grabbing the data from the view or grabbing the events from the view and then processing whatever needs to be processed, sent to the model, saving, storing data, or retrieving data if it's asking for something, and then processing that again, and then delivering that to the view. So that's basically an architecture. Model view controller is a way to build systems. It's the architecture you're going to build your system on top of. It can be, obviously it can be coded for front-end and back-end devs. Full stack devs can create everything from the beginning to the end. When I mean everything, like they can create from the view, the model, the controller, everything. While if you get like a backend, usually backend guys are going to be working only in the model and the controller. And then the front-end guys are going to be working in the view, sometimes in the controller as well, but most of the time in the view. That's going to lead us to the next term, which is microservices. Microservices is a different architecture. It's a bit different from model view controller. You can use model view controller inside of microservices, but it's a bit weird. But microservices, basically, you can think of a service being used by another piece of software. So microservices usually, when we split the architecture and we split many features of a software in services, which are going to be consumed by one piece of front end. So we're going to have one front end usually. It's not a rule, but usually we have one front end consuming many microservices from the back end. For example, authentication. When the user is going to log in, there's a microservice in the back end providing that authentication service. And that's the only thing that does. It only authenticates the users. That's one microservice. Then you can have another service just to give you the weather. You can have a microservice just to provide you what's the current temperature, for example. So there are many microservices in the back end. When you start to understand a bit more of a system, it's easier to give you an example. It's a bit hard to give an example to beginners, but you can think as a whole bunch of services. That's why they call them micro, because they're like just a small piece of thing which has a very specific function, and it's gonna work like a service. It's gonna deliver that to the front end to use it. And then when we talk about web development, I've talked before about HTML, and what HTML is, that one you probably heard about. Even kids in the school, they hear about HTML these days. And HTML stands for Hypertext Markup Language. Some people say it is a programming language. Some people say it's not. It's just a markup language. To be honest, it doesn't matter if it is or not programming. But what matters is that's the way you're going to build your interface for a browser. Basically, whatever you see inside of a browser, inside of Google Chrome, Microsoft Edge, or Safari, whatever you see inside of that is based on HTML. It's built on HTML. So HTML is the way you code the screens to be displayed. You code the page to be displayed in a browser. Most of the time, not only browsers can process HTML these days, but that's the most common one. And together with the HTML, you're usually going to see the term CSS, which stands for Cascading Style Sheets. So HTML is where you're going to build the interface, and style sheets is where you're going to build your styles. So you can build, put colors in things, put borders, adjust the background, basically all the style, all the visual stuff you're going to be doing in the CSS. So it's a combination of HTML and CSS, which builds the interface, which builds like what you can see. And then to make those things interactive, to make those things change while you are using that, we do have JavaScript. JavaScript is a programming language. It started in the front end. At the beginning, it was only running inside of browsers. These days, it actually runs in the back end as well. So they create some extensions like Node.js, which can run JavaScript in the backend too. JavaScript is the programming language. At the beginning, as I mentioned, it was built for running inside of a browser and to do dynamic stuff inside of the browser. But now it's very powerful. It is object-oriented, as we talked before, and it can do a lot of things for you. It's basically a complete, like a very comprehensive language, and that's the one I definitely recommend you to start with. If you are starting your career, if you are starting learning programming, I definitely recommend you to start with JavaScript. So if you learn the basics of CSS, HTML, and JavaScript, you're going to be able to build very cool stuff at the beginning. Like, I would say probably you can apply for junior positions. If you already know HTML, CSS, and JavaScript, you can start to apply for jobs. That is enough to build simple things already. It is enough to get your first job. Let's go to the next concept. Next concept is AJAX. AJAX stands for Asynchronous, JavaScript, and XML. For you to understand that easier, we can think about a web page. You know, web page is static. When you load a page, it is in front of you and don't do anything. But then imagine you have to retrieve some data and you don't want to reload the page. AJAX is the way to actually send a call to the backend and retrieve some data and update your screen without reloading the page. Because every time you reload the page, it's a new request to the backend. You have to bring all the code to the interface and rebuild the interface. If you don't want to bring all the code and rebuild your interface or reload the page, we can use we can use AJAX to actually just send a request, grab a small portion of data, and that update a small part of your screen. So AJAX is basically an asynchronous way to communicate with backend. And asynchronous because it's not reloading the page. It's not synchronous with the page loading. And also in the front end, in the web dev, we have DOM, which stands for Document Object Model. DOM is basically the representation of the HTML page in a programming language. So you can use DOM with JavaScript to actually change stuff in the page. If you combine AJAX with DOM manipulation, that's a very powerful tool. So DOM is basically the model of your document. When you have a web page, you have an HTML document. And then you have that object model. It's a way to actually interact with, using a programming language. You're going to interact with your page, basically, with your HTML code or whatever you have inside of the browser, as those things were objects. So you're going to get them as objects and interact with them. And then we have another very common term in the web development, which is JSON. What JSON is? JSON stands for JavaScript Object Notation. That's basically a notation for text data. It is, at the end of the day, it's text. And it is data usually sent between systems. So we spoke before about APIs and REST. JSON is basically the way they actually send data through and they read data. So API is the interface, REST is an architecture for using that interface, and JSON is usually the data, the way they structure the data. That's the notation, how they write the data. So it's basically using brackets and curly brackets and square brackets to define objects, to define arrays, to define things you're going to be storing as data. So you have a key value pairs. That's basically JSON. What JSON is a notation for exchanging data between systems, basically. We also spoke before about HTTP, and I'm going to extend that to HTTPS. That stands for Hypertext Transfer Protocol, secure in the case of S. What that basically is the protocol we use to communicate through, I wouldn't say through internet. We have many other protocols through internet, but that's the protocol we use to access web applications. So every time you hit something in a browser, for example, the browser is looking for the HTTP protocol. It's connecting to a server through HTTP. That's the way your computer connects to any server you are trying to read things from. And that's just a protocol. Protocol basically means a set of rules, how these computers, they're going to communicate with each other. You're going to be hearing this term many times, but you're probably not going to do anything there. I mean, you're not going to code anything in HTTP or for HTTP. You're going to use that as a protocol as well. For example, REST APIs, they are based on HTTP methods. So there are methods in the HTTP, and you're going to base your APIs on those methods. So it's good to understand that, but you're not going to be actually doing anything on top of that. You're not going to be coding. And talking about security, in these days, it's always, I would say it's basically required, it's mandatory to use the HTTPS, which is the secure version of HTTP. What the S means, it means it's going to be the communication between your browser and the server is going to be encrypted. It's going to be in a way no one can actually intercept that. No one can read the information between you and the server. So that's why it's called secure. It's using SSL, which is another security jargon. It's basically a security layer. So it's using a security layer on top of HTTP. Let's talk about database. You're usually going to hear like DB. What's a DB? DB basically stands for database, and database is a very common term. It's where we store information, where we store whatever we are sending, records or people, whatever you have in a system. Even when we don't think of a database, for example, if you have a sports app and then you go for a run, where that run you just done, where it's going to be stored, it's going to be stored in a database, and what you probably have heard about without using these words, but you have heard about the names of them, it's an RDBMS, which stands for Relational Database Management System. It's very hard to hear that, like RDBMS, but you are going to be hearing about MySQL, Microsoft SQL, Postgres. You're going to be hearing about Oracle. All those names I just mentioned, they are RDBMS. They are database management systems. So they are systems to actually manage your database. In those systems, that's where you're going to be using the SQL language, for example. You're going to be using a SQL language through an RDBMS to actually store and retrieve data. So basically, that's what an RDBMS is. It's a relational database management system. It's a way to actually manage your database system. It's a software, and you're going to be using that software within your language, within your system. So your system is going to be using another system to store data. That was since the beginning, I would say. Relational database, they have been used for many years already, and they're still around, but we have another concept these days which work together. I wouldn't say it's going to replace that, but they work together, they work combined, and the new concept is actually NoSQL. When we talk about NoSQL, we're talking about non-relational database. So basically we have two types of database, relational database and non-relational database. And NoSQL is something you're going to be using to work with non-relational database. So the more modern database, they can use different approaches which are not relational. They can use one on big table only, or they can have like key value pairs, or different ways to actually store the data, which are not necessarily relational database. And the way to interact with that, or the way we call that, is actually NoSQL database, because you don't use the SQL language to actually interact with the data. You use another notation, or sometimes just a programming language to actually interact with the data in that database. More general stuff. We have OS, for example, which are like stands for operating systems. Basically, what it is, it's like Windows, Mac OS, Linux. That's all the operating systems. So when you see someone talking about OS, you already know like they're talking about your Linux or your Windows. We also have the concept. We also have the concept of UI and GUI, which is graphic user interface. Basically, that's all the interface used these days. Like more than 40 years ago, probably we had like the text interface. That's the way people used to interact with the computer. These days, like all the normal users, normal people were using graphic interface. For system admins, for people who actually work in the IT department, they usually use the terminal, which is still like the text user interface, but most of systems and everything you use, they're graphical. What means graphical? Graphical, basically everything you can see in the browser or the apps you use in your phone, everything like it's a graphic interface. So when you hear the term GUI or UI, it's talking about graphic user interface. There's even a professional or a role called UI designer or GUI designer. What's that? It's the guy who actually creates the interface. So basically that's what UI means. You're going to be hearing that a lot. What's the UI? Another term, I actually forgot to write that down here, which usually you're going to see with UI is UX. UX stands for user experience. So they are used combined, like UX and UI, because they work together. What's the user experience? It's based on the user interface you have. So you have an interface, it's going to give the user an experience on using that interface. So we have UX and the UI. Another term, it's IP address. So let's talk about networkings now. IP address, basically they are the address of your computer in a network. So you can have your internal network at your home, at your place. You're going to have a router, you're going to have a network. IP address is going to be the address of your computer. But also it is the address of the computers on the internet. So your router, when your router is pointing to the internet, it's interfacing to the open world, it's going to have an IP address as well. That's the way the data is going to send straight to you. So you can compare that with normal addresses and streets. That's the address the computers can understand. So you're going to be hearing that many times. And that's no mystery here. It's just like the way to address your computer, to address your home, to address your local stuff. So IP address is address of a device in a network, basically. And that leads us to another term you're going to be hearing, which is DNS. DNS is something in the networking area, which most of the developers, they ignore, they don't know, but it's very useful. I mean, most of the beginner developers, the experienced ones, obviously, they know what's that. But the beginners, they mostly ignore that when they are learning a language. And then when it comes to actually deploy stuff, they don't understand how the internet works. DNS is basically the way the internet works. It stands for Domain Name System, but it's what actually translates the names. You know, when we have google.com, that behind the scenes, it is an IP address. Google.com is not an address. What is an address is an IP address, which is a big number. And that big number, no one knows that. It would be very hard for people to know how to type a big number to actually get access to Google, for example. So they built this domain name system, which is what's going to convert the names into addresses. And that's going to make you able to actually reach the servers and reach the system. So when you type google.com in your browser, what it's going to do, it's going to reach a DNS server. That DNS server is going to convert that name in an IP address, and then your browser is going to try to access that IP address and retrieve you the information which is in Google. So whatever is in google.com or whatever is in the IP of google.com is going to be retrieved to you. So that's what DNS means. That's basically the way internet works, or the way the web works. You also have VPNs. You probably heard about that when you were talking about secured stuff, or when you are in a country where you can't access some stuff. You have to use a VPN to get access to some stuff you were not allowed to in some place. That's the most common usage for normal people. But also we have that in enterprise companies. Most of the enterprise companies, they require you to use their VPN, which stands for Virtual Private Network. What's a private network? Private network is a network, as the name said, private, like just for a few people, just for authorized people. And when we say virtual, it means we can use that through the internet. So through the internet, you can access, you can get access to a private network. You can access your company network through the internet. So through a VPN, you can be overseas, but you can actually simulate, you can fake like you are inside of your office, your company office. So you're going to connect through the internet with like a tunnel from wherever you are to your company office, and then from there you're going to hit the open world. So you're going to hit the internet, basically. That's what a VPN is. So it's a way to create a tunnel between where you are and where is your VPN actually running. Let's talk about software deployment. First thing about software deployment, you probably have heard a lot about it, is cloud computing. What cloud computing is? Cloud computing is, I wouldn't say modern because it's been around for many years already, but it's a way to actually have your systems in the cloud. And when we say in the cloud, it is, it's hard to explain that without explaining how it was in the past. In the past, you usually have a server, which was a computer in a data center. And every time you have to deploy like a website or a web system, the devs, they have to be worried about which server their code or their system was. So they had to deploy to one specific server. If that data center had a problem, like with connections and things, the website would be down. And that was a worry for devs and for dev teams and for infrastructure teams of the system, for the people who build the system. And then they bring this cloud computing, which is, we don't have to worry about that anymore as a devs and as an infrastructure team for the company who is building the system. And we're going to give that responsibility to another company like Amazon, like Google, or like Microsoft. They all have their cloud and computing stuff. We don't have to be worried about one server, but we are going to be deploying our stuff to the cloud. The cloud, you don't know which server specifically you are on. You just deploy that to Amazon, and Amazon is going to put that somewhere where you don't know. So you're still having the server and the concept and everything, but when they say cloud, it's usually a bunch of services combined together, which we're going to just consume those services. You're going to consume services for database. We're going to consume services for processing data, for running some code, for running some functions. And that's going to also bring us to another concept I just reminded, which is serverless. Serverless is very connected to cloud computing. It's because we're going to using services for doing stuff without really creating the server-side code. So you can just use a service like a Lambda function, for example, in AWS, to run a specific piece of code and retrieve some data from somewhere else using a database, which is going to be a different service, and just bring the data for the front end. So that's what cloud computing is. Like, you can see that as a set of services provided by one provider, and you basically don't know where it is. It is in the cloud. That's why they call it cloud computing. And also we can talk about CI and CD. That's about software deployment. If you never heard about it, it is about continuous integration and continuous deployment. What does that mean? Continuous integration means when you work in a team, you frequently have to put your code together and test all the devs' code in one piece, because at the end of the day, it's one software, so you're going to have to combine your code. So continuous integration is basically, as the name states, you're going to be continuously integrating with other devs' code and it's going to be tested. It's usually used combined with automated tests. So when you have continuous integration, it's going to be integrated and then tested by automated tests. And that's going to lead to the next step, which is after committing, after checking a piece of code, it has to be deployed to the whole system, to the users, to the final users. It has to be deployed. So it also goes to the continuous deployment. You're going to have continuous integration, usually some automated tests, then you have the deployment. And that happens all the time. All the time someone checks something, or the time someone finishes some piece of code, it can be deployed. And that's the opposite of the oldest approach, which was actually having batches of deployment. So you have sort of batch, and you will agree in one day, and then that day you deliver a batch of things, a lot of things you have done in the previous month, 2 months, 3 months. Some companies, they even had like 6 months release, which is completely the opposite of the continuous deployment. So CI and CD means like you're going to be continuously integrating your code and continuously delivering your code. Still talking about software deployment, I mentioned before we have those providers for cloud computing. AWS is the most known one. You probably heard about AWS, which is Amazon Web Services. But Amazon is not the only one. We also have Microsoft Azure, and we also have Google Cloud. So that's the 3 main providers, the biggest ones. We do have others, but most of the world is using one of those 3. And last but not least, we have the concept of Git and GitHub. What Git is a version control system. And when we talk about version control, we're talking about controlling the version of your software. So not the version of the software itself, but a version of every single file of code you have. So every time you enhance your code or you fix a bug or something, you're going to be checking in on Git, and Git's going to take control of all the versions you have. Let's say if you introduce a bug and you want to go roll back to a previous version of your code, you don't have to be commenting out code. You don't have to worry about, I'm going to save that function for later, even if I'm going to delete that because I can use that in the future. Don't worry about it, because the version control can give you that back if you need. So if you just roll back to a previous version, and that's going to have all your versions, it's going to store all the versions of your system. That's going to be very handful when you have to roll back and you have to bring some data, some code from the past, or when you introduce a bug and you want to see what was introduced here, what's the problem here. So you're going to just go back a few versions, see the difference between the current file and the old file, and see what you have done wrong. And most people get confused about Git and GitHub. Git is just the version control system. It's about control your software. You can install Git in your computer and use that in your computer only if you want. Or you can have your own Git server, which is going to save the files for your team. It's going to be your server. But GitHub is a service provider. They actually provide the service for Git. You can pay them a fee or even use that for free. Most of people use the free version of GitHub, where you can actually store your data. It's going to work as a server for version control. So you're going to put your code in there, and you're going to use GitHub as the server for the version control, but you're going to still having your version control and everything. We do have a lot of other providers, for example, Atlassian. The Atlassian one is called Bitbucket. So if you are in Australia, very fan of Jira, Confluence, and all those tools, probably you're going to be heading to Bitbucket instead of GitHub. So don't confuse Git with GitHub, which most people actually confuse that. Don't be confused. And I think that was it, guys. I hope this video was helpful. That was all the terms I had to you. Obviously, there are a lot more. I didn't have the chance to cover all of them, but I'm pretty sure on knowing all of those, you're going to be feeling a way better when you are in a conversation. So if you go to a meetup, or if you are in a job interview and you want to look cool, looks better, looks like you know really a little bit, you know a bit more than what you know, it's actually going to be very helpful to you. So guys, thanks for watching. Thanks for staying with me for that long. And I hope that video was useful. Don't forget to leave your thumbs up and share this video with someone you think it's going to help them. Thanks, guys. See you next time.